What's up, team? Today we're going to start talking about exponential functions. I'm calling this part one because there's going to be a part two. So you can see our learning target. I can solve an exponential function when given an a value, a b value, and an x value. And then I can create tables and graphs using this data. So that's what we're getting ourselves into today. Let's dive right in. So with our a, b, and x value, well, we have an exponential function. All exponential functions look like this all the time. There's going to be different numbers, but this is the general format. F of x equals a times b to the x power. So, of course, order of operations is going to be b to the x power, so b times b times b, however many times x tells us, and then we multiply it by a. Here's how you find each of these things, or here's what they mean. The a value is our initial value, so there's going to be some sort of value that you start with, whether it's amount of money or number of items sold, or something along these lines. We'll do an example to kind of make sense of that. But there's going to be some sort of initial value, some starting point. That's your a. The b value is your multiplier, so that's what you're multiplying by. So, for example, if something doubles in value every month, year, whatever the case may be, the multiplier will be 2 because it's doubling. Sometimes it'll be 3 or 4. Sometimes it'll be like 1 point something. There's all sorts of different potential scenarios here. And then the x tells us how many times we're going to multiply or apply our multiplier. So this would be like if you're supposed to use a multiplier every month, so say something doubles in value every month, which is kind of crazy, but let's pretend that's the thing. That means every month you have to multiply your thing by 2. So if you're talking 5 months in the future, your x value is going to be 5 because you have to apply this multiplier 5 times. Okay. I'm going to set up an example for us, and we're going to put this to work. So let's pretend that we have a business. We are selling masks, and we have a little bit of data to work with. So say we started our business, our class, business selling masks in December of 2020, and that very first month, we made $1,000 profit. So I have that captured here, $1,000 profit in December 2020. January 2021, we made $1,150. We improved. Hooray, this is great. But we want to get an idea of what we're going to be making in the future. So we're going to use this data and make some projections for the future. So what we need to do is we're going to figure out our a, our b, and an x and create an exponential function here. So a is the initial value. In this case, it's going to be the value for our 0 month is kind of what we're calling it here, our very first month. It's our first opportunity to collect some data. It's going to be our December number, so that's 1,000. Our b value tells us what to multiply by, so that's something we're going to have to figure out. And our x value at first is just going to remain x, and then we'll show you, we'll start plugging things in here. So let's capture that first piece. We know that our a is going to equal 1,000. That is our starting point here. Our b value, again, that's our multiplier, and we need to figure that out. So basically what this is if you start with 1,000, what do you multiply 1,000 by to get to 1,150? Well, we can do some real quick algebra to figure that out. So that'd be 1,000 times x equals 1,150. We just need to figure out what are we multiplying by here to make this happen, to make this work, right? So we just divide both sides by 1,000, and x equals 1,150 over 1,000. And there's a little bit of a trick here to this. You could just plug this into your calculator. 1,150 divided by 1,000, you see here I got 1.15. Now, if you didn't set up this equation and you just took the big number, divided it by the other number, as long as you're working with your first kind of data point and your initial data point, this is going to work just fine. So the 1,150 divided by 1,000 is 1.15, and that's going to be our multiplier. 1.15. So that means that we're growing by 15% in that month, because 1.0 would be 100%, right? That's just the initial value. That'd be 1,000. But if we're growing by 15%, we have our 100, and then we're taking on an additional 15%. Now our x, in this case, again, is just going to be x. We're setting up an equation in terms of x. We're setting up a function here. So to do that, it would just be f of x equals, now I'm just going to use this as a model. A times b to the x, in this case, is going to be 1,000 times our b value, which is 1.15, and then we're going to have our exponent right up here like that. Now what we can do with this is we can set this up where we can project anywhere as far as we want in the future X number of months. So say we want to go 6 months in the future, 10 months in the future, whatever that value is, we would just plug it in here for X. And we're going to do that here in just a moment. Okay, we're going to set up a table and plug some things in. So my table here, I have an X column and an F of X column. We're used to X's and Y's, but remember F of X is really just Y in function notation. The X here stands for the months after December of 2020. So the way I have them labeled is when X equals 1, that's January. It's 1 month after December. 2 is February, etc. We know how that works. F of X is our profits. That's how much money we're going to make in a given month. So in order to find these values here, we're just going to plug stuff in. So for here, when X is 1, that means we're looking for F of 1, which means we're going to take this function here, 1,000, times 1.15. Now we have this X here, but X equals 1, so we're just going to plug in 1 right here. So 1.15 to the first power, obviously that's 1.15. You don't need to multiply it by anything. That solves this piece, and then we need to multiply that whole chunk by 1,000. Little shortcut here, it's already given to us. We know what it's going to be. It's $1,150. We are going to have to do that for the rest of them, though, and it's going to get a little bit trickier. So I'm going to bust out my calculator. Keep this handy. You're going to use this a whole bunch of times. And I'm going to show you something real quick here, too. So 1.15 to the second power is what we're going to have to do that next, then the third power, fourth power, fifth power. That can get annoying because to the fifth power, that's 1.15 times 1.15 times 1.5 times, right? That's annoying. But there's a function on your calculator that you can use as a shortcut. So if I want to do 1.15 to the fifth power, let's say, I'm going to press this button right here with a little arrow called a caret, and then we type in 5. So this is 1.15 to the fifth power, click equals. You get this, and we'll round 2.01. So we're going to be using this moving forward. I'd also be happy to show you. I'm going to pause this and get my phone calculator out so you can see how to use that as well. Okay, I got the iPhone calculator. Open it up, turn it sideways. Very similar, 1.15. And then now you're going to press this X to the Y power button. It's kind of a funky one, X to the Y power. That does the same thing that the caret button would do on a calculator. And then you type in whatever exponent it is. In this case, it's 5. And we get the same result. So you can use this if you need to, not on quizzes. So you have to learn how to use this on a real calculator or Desmos or whatever the case may be. Okay, let's use this to make a projection. Say we want to figure out what are our profits going to be in October of 2021. Well, I should point out, I did fill the rest of these out. I just plugged them into my calculator, 1,000.1.15 to the second power, to the third power, etc. I'm not going to walk through the PEMDAS. You should do this on your own and then check to see if it matches what I have here. So now our projection, our profits in October of 2021. So we just need to use this formula here, but we need to plug in the correct X value. Well, October is the 10th month of the year, and we know January's X value is 1, February is 2, etc. So our X value is going to be 10 here. So all we need to do is we're going to say that X equals 10. So we're going to find not F of X, but F of 10, which is 1,000 times 1.15 to the 10th power. Now, I don't know what this is. I'm going to get my calculator out. I'm going to type in 1,000 times 1.15 to the 10th power and click equals. See what it says. It looks like we're making about $4,000, just a hair over $4,000 that month. So F of 10, or our profits in October of 2021, is $4,045.55 from our mask business. Now, we're not always going to grow the same rate every month. It doesn't always work like this. I get it. There are limitations. But assuming that we grew 15% each month, that's where we'd land. Another hole in this is that hopefully we won't need masks in October of 2021, but who knows, maybe we'll watch this video in the future and laugh. So that's that. I want to do one more thing. I want to look at a graph of this data. Now this graph is not going to be super complicated. What I'm going to do is create an X and a Y axis, and I'm just going to plot these dots, and we're going to kind of look at what the shape looks like. And that's it. So hang on for that. Okay, we have our graph. X-axis here are the months beyond December 2020. These are our X values from that table. Y values. This is our monthly profits. These are F of X from that table over there. You'll see we go from 1,000 to 2,000. I went up by 100-degree increments. I also put this break in the graph. That just means, like, it's just a note to the audience, like, hey, there's nothing down here. I cut that part of the graph out because there's no data down there. So that's okay. That's a good move. And then I have the months, 1, 2, 3, 4, and 5, again, just from the X values here. I plotted the dots. At 0 months, we're at 1,000. At 1 month, we're at 1,150, etc. It's all just those numbers. First glance, this looks like a straight line that goes up, but you'll see, I'm going to carefully do this and probably screw it up, but you'll see when you start to connect the dots that it is not actually it's not only not a straight line because of my bad drawing, but you'll see, oh geez, that's not great. But you'll see it starts to bend upwards. It has in this particular example, it's kind of gradual, but the further out you go, the more steep that slope gets. You'll notice it more clearly when we have multipliers like 2 and 3 and 4 and stuff, that it gets real steep real quick. So the takeaway from this is an exponential growth function is not going to make a straight line. An exponential growth function is going to start off growing kind of slow, but then it's going to grow, it's going to go up very, very quickly. Exponential decay is different. We'll talk about that one next time. Okay, practice problems are on Classroom. Let us know if you have questions.